So, thank you so much. All right. So, here at the top, most of all of our information is at the top, so we're good. Thing to remember is when you check your conditions, we want independent random samples. And you want to make sure you state that it's 2 independent random samples, okay? And if you need to check independence in large counts, check for both populations. Okay, we've got to make sure to show that you've checked for both. But remember, we're switching gears here. We're switching to means. So how do we check for normality? Okay, CLT is one option. What's another option? Drawing the dot plots. That's your favorite one, right? What's the third option? Do you remember? Stated. Good. If it's stated that it's normal, the population is normal. Doesn't happen very often, but if it's stated, that's all you have to say. Stated. So most commonly used is the CLT. Thank goodness, right? All right, then there's your 4-step process. Not a whole lot has changed here, but here is the name of the test, the 2-sample T interval. That's the name of that test. And soon we're going to start generating a list of the tests that we've learned so that you can kind of see where we're headed, okay? Now, let's dive into this question. All right. The most recent American Time Use Survey, conducted by the Bureau of Labor Statistics, found that many Americans barely spend any time reading for fun. People ages 15 to 19 average only 7.8 minutes of leisurely reading per day, with a standard deviation of 5.4. I'm going to highlight that. Seems like I need to know that, right? You do you. However, people of ages 75 and older read for an average of 43.8 minutes per day with a standard deviation of 35.5. These results are based on random samples of 975 people and 1,050 people 75 and over. All right. Construct and interpret a 95% confidence interval for the difference in mean amount of time in minutes that people age 15 to 19 and people ages 75 and over read per day. The nice thing about this, if you just train your brain to look for the parameter, it's already defined for you in your STEM, like right here. So when I define my parameter, it's the difference in mean amount of time that people, right there, I can copy it down word for word. And that way you're not going to trip yourself up with using the wrong language. So in my state step, we are looking for the difference in mean. So mu1 minus mu2. And I'm just going to literally write what it says. It's the difference in mean amount of time that people age 15 to 19 and people ages 75 and over read per day. Now I might define here mu1 is going to be the age 15 to 19 group. Mu2 would be the ages 75 and over group. Just so I've cleared up somewhere what those are going to represent in my question. I should probably say mean reading time. And you can, I don't know if I mentioned it in this class, you can just write little ditto marks, so you have to rewrite everything. Mean reading time for 55 plus ages. All right, so I've defined it there. The reason I thought that was important is because mu needs to represent a mean. They might dock you on that if you don't say it's a mean something. Okay, there's my state. I'm doing a 95% interval. Let's do the plan step. All right, what is the name of our test or procedure, I should say? Good. It's a 2-sample t interval. Now we got to check our conditions. So random. Are our 2 samples independent and random? Yep, so I just got to say that. 2 independent random samples. Do I need to check the 10% rule on this?
Yeah.
Think about this. Is this an experiment or an observational study?
It's an observation.
It's just observational, right? There's no treatments imposed. So it's observational, so I need to do 10%. So let's think about this. There's 975 in that first group. Oh. Is that less than 10% of people aged 15 to 19? I think so. And then 1,050 is less than 10% people aged 75 and up. Yes. All right, then we check for normality. Will the sampling distribution be normal? What tool do we use on this one? CLT works lovely, doesn't it? So all I got to do is just show it. 975 is greater than or equal to 30. So by CLT, that one's good. 1,050 is greater than or equal to 30. By this CLT, I'm good there too. Okey-doke. The do step. All right, when you're doing the 2-sample business, you don't have to write the formula unless you just really feel compelled. So X bar 1, S1, N1, that was all given to me. The average was 7.8, standard deviation was 5.4, and there was 975 teens. X bar 2 was, what was it, 43.8 minutes. S2 and N2 was 1,050. And my confidence level is 0.95, right? So find this in your calculator. Stat test. We're looking for 2-sample t interval, so be careful. It's test 0. Let's see, when it says ask for pooling on this, what do we do?
No.
We always say no to pooling with means. Okay? All right, what does this generate? It gives us this interval, negative 38.18 to negative 33.82. Stat tests, and then you scroll down to test 0. Everybody get that? Everybody know why we chose stats instead of data?
Yeah.
Yeah, because it gave us the statistics, right? We didn't have to enter all the data. We like it better that way. Now, stop and think. Does it make sense that our interval is negative? Why does that make sense?
Because YouTube is a bigger number because all people read
mu2 is the larger number here because older people tend to read more, so it makes sense that the difference would be negative. We're very clear on that? Okay, so now we do what? Conclude? How does our statement start? We are 95%, yep. Confident that the interval negative 38.18 minutes to negative 33.82 minutes captures. Here's where I would jump back to my parameter statement in the state step and just rewrite it. the true mean, or true difference, I'm sorry, in mean time read per day. Running out of space there. Hopefully you have more space. Can we handle it? Questions about it? It's just an interval. Same structure we've done before, very similar. All right, you ready to try a hypothesis test?